Hello everyone, today we'll be doing a lesson on perpendicular and angled bisectors and triangles. So first, just for a vocabulary word, is something that we're going to be seeing quite a bit here is equidistance. And what that term means is that it is when a point is the same distance from two or more objects. So it kind of sounds like its meaning equal. We see that looks like equal and distant distance. So it's when a point is equal distance from two or more objects. And we have two theorems that are dealing with perpendicular bisectors with triangles. The first is in a plane, if a point lies on the perpendicular bisector of a segment, then it is equidistant. So there's our word again. From the endpoints of the segment. So we see in this picture here, we have a point C, and the point C lies on the perpendicular bisector. And remember, perpendicular bisector, that just means that this line is perpendicular to the segment. So we see that line CP is perpendicular to AB, and AC that's bisecting it. So we have that AP is congruent to PB. So it's perpendicular, it's intersecting at that right angle, and it's intersecting right in the middle of that segment. And it says when this happens, then my point C is equidistant from the endpoints of the segment. So A and B are those endpoints. So what does that mean? Well, it's meaning that C is the same distance away from A as it is from B. So we end up with congruent segments here. So in other words, if CP is the perpendicular bisector of AB, then AC is equal to CB. So anytime we have this perpendicular bisector, this triangle that we can kind of just form, those are going to be the same distance away. And then we see with this theorem that the converse is actually true as well, so we can reverse the order of this. And that says, in a plane, if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of the segment. So in other words, if DA is equal to DB, then D lies on the perpendicular bisector of AB.